So in our last example, we could have either done dy dx or dx dy because we had a rectangle. So I want to talk a little bit about looking at the order that you integrate in. So let's look at this example. Let's find the volume of the solid region bounded by the surface f of xy equals e to the negative x squared, and the planes z equals 0, y equals 0, y equals x, and x equals 1. So if I'm looking at my region in my xy plane that I'm integrating over, I'm looking at these equations here and I see I'm told y equals 0, y equals x, and x equals 1. Right, so if I look at these regions, right, here's y equals x, y equals 0 is here, and x equals 1 goes here. So this is my region right here, this triangular region that I'm finding, that I'm integrating over. This is R. So let's look at our two orders of integration. So here, if I set up my integral with my strips of vertical, right? So here, the order of integration would be, I'm integrating my function, which is e to the negative x squared. It'll be dy dx. So here, if I describe this region, x would be between 0 and 1, and then y would be between 0 and x. So my integral will look like this. Now if instead, let's say I want to integrate with respect to x first, so same region, but now I'm going to set up my integral a little bit differently here. I'm going to look at strips horizontally now, and I want to describe this region. So now my y values go from 0 to 1, but now x is between, so here you're looking at right function and left function. This right function is x equals 1, and this left function is x equals y. So here, the integral would be from 0 to 1 and y to 1, e to the negative x squared dx dy. So you have two options here on how you compute this volume. You can use either this integral or this integral, but what you should do is you should stop and think about integrating these. So if I look at the one on the left here, I'm integrating with respect to y first, and there's no y's here, so that is all a constant, which is easy for me to integrate. But here, on the right, I'm integrating with respect to x first, and here I have x's, and this function here is not easy to integrate with respect to x. If you try any of our integration techniques, they won't help you compute this integral. So if I go with the integral on the left, it's easy to compute, but if I go with the integral on the right, it's impossible for me to compute. So we're going to use the one that's over here on the left. So we're going to compute, to get volume, the integral from 0 to 1, 0 to x. And we said that there's no y here, so this would be the integral from 0 to 1, e to the negative x squared y. And if I plug in my bounds here, I get the integral from 0 to 1. This is e to the negative x squared x. And what's nice is I can now do a u substitution here. And what would u be? U would be negative x squared. So if you do u substitution here, you should get the integral being negative 1/2 e to the negative x squared from 0 to 1. And then you're going to plug in negative 1/2 e to the negative first minus e to the 0, which is 1. So let's see, if I distribute, this will be negative 1 over 2e plus a positive 1/2. If I get a common denominator and combine them, it'll be e minus 1 over 2e. And that is the volume. And this is a volume here. You're calculating volume. You should get a positive answer. This is positive because e is a number bigger than 1, so the numerator will be positive. The denominator will be positive, so overall you're getting a positive value, which you should be getting.